Diksha Didi, good evening.
I know.
Alright, so today we are going to continue with the size of operator where we left, right? And we were on find the size of the union, so let's just continue.
Okay.
So using the let's have a quick recap. Using the size of operator, we saw that we can take out the size of any element, right? So for by size we refer to like how much memory it will occupy, right? So over here we were on find the size of union. Before that we have done find the size of structure. We found the size of so we did nesting of size of operator also. So we had size of inside of a size of operator, right? Then we had we found the size of pointers, right? And we found out that every pointer that we save in a pointer variable, that memory location is 8 bytes, like is saved in 8 bytes. Then we found the size of the class, right? Then we found the size of an array. We found the size number of bytes taken by an expression, right? So when we did a plus g, so we added different different sizes of numbers, right? So we had int a that was saved in 4 bytes, long x that was saved in 8 bytes, double p that was saved in 8 bytes, float g that was saved in 4 bytes, right? So we added all of like we made combinations and added these, and then we noted the sizes that we obtained. Next we also took out the size of variables of different data types, and then we took out the bytes taken by different data types, right? Finally we are on uh, find the size of the union. Alright, so below is the C++ program to implement the size of operator to find the size of the union. Alright, so over here we have union GFG. So about the union data type we are going to see in detail further in this tutorial, right? And right now we are just going to look at it with a size of only, right, for now. So over here what over here we have union is very similar to structure over here. So structure also we did struct GFG, union also we are doing union GFG, right? And as we declared variables in a structure, similarly we are declaring variables in the union, and then we are creating its instance and saving it in G. Same over here we were doing with the structure. When we took out the size of the structure, we got 28, as 20 was the size of this character array, and then 4 was these 4 was integer, 4 was float. So added up together we have 28. That was the size of the structure. And over here size of the union is, over here we are getting 8, because this over here what is happening, let's just run this ourselves. So we are getting size of union 8. So it does itself it basically sees how much memory it has to occupy itself, right? As memory is a very unpredictable thing. When working with memory, you don't know what the computer is going to do and how much memory it is going to take up for your basically any element, right? So over here union we expected it to be 12, like double is 8 bytes and integer is 4 bytes. So we expected it to occupy 12 bytes of memory, but it's only occupying 8 bytes of memory. And it depends on data type to data type how much memory it will occupy. So without going into the deep why it is occupying 8 bytes of memory, we're just going to look we're just going to understand that over here union was occupying 8 bytes of memory, right? And if we had a different union with different elements, so like, or variables, so if we instead of int we said double z, then we most probably will get a different result, or we are getting the same result only, right? So the compiler itself knows how much memory to allocate to each data type or each variable or each collection data type. So we can't ourselves tell how much memory each like over here we are creating a union, right? So we were assuming over here it occupied 16 bytes, right? So we assumed its behavior to be normal like the struct, but no, the compiler does saves different elements different type in different type in different amount of memory, and it knows how much memory to allocate to each like data type. So let's not just go into the deep, and we just saw that over here the size of the union is 8 bytes, right? That was important. So next we are on the scope resolution operator in C++. Alright, so in C++, the scope resolution operator is this. So if you remember, we are using the double colon operator with namespaces also. So when we did not say using namespace standard, then we gave the standard namespace, and then we give this operator, that is a scope resolution operator, to tell if an element or a variable is inside your namespace, right? So we're just going to see that over here. Like when we were not giving using namespace standard, we were doing it like this, right? So not like this, we were doing it like not over here, so sorry. We were doing over here with standard cout, right, over here. So we gave standard and the scope resolution operator. Scope resolution operator over here is telling that cout is inside standard, right? So this operator, that is a scope resolution operator, is telling us that. So it is used for the following purposes. So there are many purposes of the scope resolution operator. Two. One is to access a global variable when there is a local variable with the same name. So when, let's just revert all of this code. Alright, so when you have the local variable with same name and you want to access the global variable, then what you can do, you can use the scope resolution operator. So over here we are saying value of global x is scope resolution x. So when giving the scope resolution operator over here, what it is taking, if you don't give anything before it, it will automatically take as you are trying to access the variable, the global variable, right? So x, you are trying to access the global variable x by giving the scope resolution operator before it, and before the scope resolution operator we don't have a left operand, we only have a right operand. Then only it is going to try to access your variable globally, right? If you give a left operand, for example standard, that will check for x in the standard namespace, right? So we don't want that in this case. We want to access the global variable, though there's a local variable with the same name. So when using normal x, we'll get the value of the local variable, but when giving the scope resolution operator before x, we'll get the value of the global x variable. So over here we are getting value of global x is 0 and value of local x is 10. Alright, so is the scope resolution, this case clear with the scope resolution operator?
That's clear.
Alright, great. Next we are on to define a function outside a class. So over here this is a C++ program to show that scope resolution operator is used to define a function outside the class. So what we have a class A, then we are giving the public access modifier, and then we are saying void fun, right? So we are creating a function, we are declaring a function, right, named fun, and we are giving the return type to be void, so we are not returning anything. Next what we are saying void a, right, and then we are saying colon scope resolution fun. So what this is saying, void is the return type of our function over here. A fun is accessing, right? So it's saying access the function inside A. So this is the definition outside the class for the function inside the A class. So we are saying void A's function. If we didn't give A scope and the scope resolution operator, then this would have created a fun method outside this class also. But what we are saying that inside the A class, define the function. So whichever function is declared, give it the definition but outside the A class. So we are giving A, then we are giving the scope resolution operator, right, as this work can be only done with the scope resolution operator. Then we are telling which function's definition we want to give, and then what we are doing, we are saying we are printing fun called, right, and then we are creating an instance of the A class. We are saying A dot fun, right, so that will print fun called, right, and in the end we are just going to get fun called. So over here, this was the example of declaring your function inside the class and then giving it a definition outside, right, by giving the A name before and then the scope resolution operator. So basically giving the class name and then the scope resolution operator. Next, we have to access a class's static variable. So we as you know, we saw how to create static variables. So there let's just have a quick recap. There were two types of variable: normal class variables and static variables. Normal variables were accessible on your object, right? So object of the class. So in this test class, if we create a variable normally like int z, right, then how will we be able to access it? By creating an object, right, and then we would be able to access that variable. But static variables, what we can do, instead of creating an instance, we can directly access on the class. So we can directly use the test class to access your static variables, right? So this is the use of static variables. So instead of being accessed on objects, they are accessed on the class name itself. Now we are going to see how to access static members, right? So we have created static members, but how should we access them, right? So we are just going to see, and it is basically done using the scope resolution operator, right? So over here we have a test class in which we are creating an x variable, static variable, right, and then we are publicly we are creating a y variable, and then we have a function which is taking in an x variable, right, and we have a function which is taking in a parameter, right, and the parameter name is x, right. So what if we want to access the variable that was over here, right? So if we wanted to access the x variable that was over here instead of the parameter value, then what we can do, we can't just directly give the scope resolution operator an x. We have to say that first test in the test class access x, right? So from the test class we are accessing x, right? So what this will do, this will take out x's value from the test class, and then it will print value of static x is this, whatever it is. Right now it's 0, right? And then what we're doing, we have value of local x is, we are just normally using x, so this will normally use the parameter x that we were getting over here. But to access the x variable that was over here, the static variable, that we had to do test, and then we had to use the scope resolution operator and then x. So we are creating an integer, we are saying integer test x equals to 1. So in C++, static members must be explicitly defined like this, right? So explicitly we are over here, just what we are doing, we are giving these static variables an explicit definition. So we are saying int test x is equals to 1, right? So we are setting the value of x to 1 or inside the test class. Then we are saying test y is equals to 2, so we are setting the value of y to 2. And then what we are doing, we are creating an object of the test class. We are saying int x is equals to 3, right? So we are creating a variable x outside, right? So this won't affect the class in any way, but we are passing this value to our func method, right? So we are passing it 3. So first it will print 1 as we change the value of x that was over here, right? And then it is going to show 3 from here. In the end, what we are doing, we are printing test y, right? So we are accessing we are just saying we are just accessing the y variable inside the test class using the scope resolution operator, whose value we set to 2. So first we are going to get value of static x is 1, value of local x is 3, and then finally we are getting test y test scope resolution y is equals to 2. Alright, so we are getting the output, right? So I hope this example is clear. Hello. Hello.
Yes, sorry, my microphone.
Alright, I hope the previous example was clear over here. This.
Yeah, that's clear.
Alright, great. Now we are on in case of multiple inheritance. We can also use the scope resolution operator in case of multiple inheritance. So if the same variable name exists in two ancestor classes, we can use the scope resolution operator to distinguish. Alright, so over here what we have class A, in which we are creating a protected variable x, and we are creating a public method, a public constructor method in which we are setting the value of x to 10. Next we have B, in which we have protected variable x, and we have a public constructor method where we are setting x to 20. Next we have C, right, that is basically inheriting from A and B, right? And what we have in there, we just have a public method fun, in which we are saying A's x is uh, a scope resolution x, right? So we are accessing A's x like this, like it was a static variable, though we have created it like this normally int x. But as we are inheriting from A class, how can we access its x variable? By saying A scope resolution x. So using the scope resolution operator, we are accessing the x variable of the A class, that whose value was 10. Next what we are saying B's x is, and similarly we're doing the same thing with B, right? So we are taking out B's x with the scope resolution operator, right? So we are saying B scope resolution x, right? So first we will get 10 and next we will get 20, right? Then we are creating an object of the C class that is over here, that was inheriting from A and B, right? We are calling its fun method, so it will print 10 and 20, and then uh, uh, basically that was the result. A's x is 10 and B's x is 20. Alright, so we are getting A's x is 10, B's x is 20. Alright, next we are on for namespace. If a class having the same name exists inside two namespaces, so if you have a class having the same name that exists inside two namespaces, we can use the namespace name with the scope resolution operator to refer that class without any conflicts. So let's look at the example. What we are doing here, including our bits standard C++.h. So we are including the basically standard template library, that's what we call it. Then we are including the IO stream library, right? And we are saying using namespace standard, right? Next what we are doing, we are defining n line, right? And we are saying \n, right? So we are going to see what is happening with this later in the program, right? Next we have global declaration, name1 is equal to gfg, favorite language is equal to Python, company name is equal to gfg 2.0, right? Next you can also do the same thing in classes as we did in our struct example. So we have a developer class where publicly we are saying name is equals to Krishna, favlang is C++, and company is GFG, right? Next we are accessing the global declaration. So inside it's a constructor method, inside developers constructor method, in which we are getting favorite lang and company. We are and what we are doing over here, we are saying colon favorite lang and company name, right? So what we are setting what we are doing is we are saying the favorite lang, we are saying to setting the favorite lang, whatever we get, we are setting that as the favorite lang over here, and whatever company name we get, that that basically we are setting as our company's value, right? And next what we are creating an object of the developer class, right, in which we are passing it python and gfg, right? And when we print object dot favorite lang, as we when we passed python, favorite lang's value got changed, right? So from c++ it became python, right? So over here what we are going to get, we are going to get python. And when saying company name, and we are saying object dot company, right, then whatever basically company we pass gfg, right? So when we'll be seeing object dot company, we are going to get gfg, right? So over here, the this output, we are not going to get this output. So we are getting python, and then we are getting gfg 2.0. So I just can't see the I think this is I think this is a wrong example, as there's no scope resolution operator over here, right? So I could not see the scope resolution operator in this program, right? So I believe this is a wrong example, that some other example had to come here, right? But a wrong example was here. And about getting gfg 2.0 as the company name when printing object dot company, right? So basically what was happening over here, company name, it was not setting the company as the company passed over here. It was actually setting the company as the global company name that we declared. So the company name that we declared over here, right, that it was setting as the value of company, right? So company name was gfg 2.0, that was the value that was being set as the company over here, right? So that's why we were getting gfg 2.0. All right, so this example was not meant to be put over here, right? Some other example had to come here for namespace, right? So I think they added this example by mistake, right? So no worries, we are going to move on to the next and basically the next example, right? So refer to a class inside another class. So if a class exists inside another class, we can use nesting class to refer the nested class using the scope resolution operator. So what we have IOStream, we are including IOStream, we have class outside, in which we have a public variable x, and then we have inside that a public class inside, in which we have public x, static integer y, and a method foo that will return an integer value. Then what we are doing, we are saying integer outside inside y, right? So what we are doing, we are first using the scope resolution operator, we are accessing a inside class of the outside class, and then using the scope resolution operator further, after accessing the inside class, we are accessing the y variable, and it's setting its value to 5. And note, we are able to do this as the y variable was a static variable, right? Next what we are doing, we are creating an instance of the outside class a, right? And then what we are doing, we are saying outside inside b, right? So what over here doing, we are saying create an instance of the inside class. We had to use the scope resolution operator only, so we were accessing the inside class over here from this, right, and creating its instance, right? So basically using the scope resolution operator, we can work with nested classes. All right, so this was all about operators, right? Now we are going to move on to functions in C++. All right, so a function is a set of statements that take inputs, do some specific computation, and produce output, right? So we have already done functions in the basic course also, so we already took an overview. Now we are going to study them in detail. The idea is to put some commonly or repeatedly done tasks together and make a function, so that instead of writing the same code again and again for different inputs, we can call the function, right? So in simple terms, a function is a block of code that only runs when it is called, right? So we have already seen functions. It helps us in reusing code, right? So we give a block of code, and whenever we need it, we just call the function using its function name, right? So here's the syntax of your function. First we give the return type, right? So what value your function will return. If it will return no value, this return type is set to void. Then we have the function name that we are setting over here as gfg, right? And this is the function identifier, right? So basically when we want to use the function, we are just going to use it using its name that we define over here. Then in brackets we define its parameters. So parameters are basically data passed to functions, right? Whatever data we need, we are going to give in the form of parameters. So in parameter also we have to specify the parameter data type, so which parameter, like what type of parameter we are going to receive, and then we have to give the parameter name. This won't affect the value of the parameter. It is just the parameter name will just set that whichever parameter is being passed will be saved in this local variable in gfg, right? So basically if 90 is being passed, so what will happen, the local variable full marks whose value will be 90 will be there inside gfg, right? And similarly we have another parameter full marks too, and in the end we have this ending statement semicolon. So this is the syntax of your function. So over here, here's an example. So we have a max function that will return an integer value, right, which will take in x and y. So we are checking if x is greater than y, then return x, else return y. So here we have the main function that is automatically called, right, and it does not receive any parameter and returns an integer. If you don't give the return statement, that's also completely fine. We are creating integer a equals to 10, b equals to 20. Then we are saying integer m is equals to max, right, and we are passing it a and b. We are passing max a, 10 and 20, right? So 10 is being saved in x, 20 is being saved in y. Then we are checking if 10 is greater than 20. So 10 is not greater than 20, so it will go in the else statement and it will return y. So y was 20, right? So 20 is getting returned and saved in m, right? Then we are printing m is, and then whatever the value we are getting, so m is 20 will be shown. Alright, so we are getting m is 20. So why do we need functions exactly? So functions help us in reducing code redundancy. If functionality is performed at multiple places in software, then rather than writing the same code again and again, we create a function and call it everywhere. This also helps in maintenance, as we have to change at one place if we make for a few future changes to the functionality. So basically it is used for reducing code redundancy, right? Basically it's all about repetition also. And basically when working with functions, we have the functionality defined at one place, and we are using that functionality using just a name, right? So instead of changing everywhere wherever you were using that functionality, instead of changing everywhere, you just have to change. Yeah, if there's an error or you had to make a change, you just have to make a change inside the function definition, right? And everywhere it will be automatically changed, right? That's one big advantage, that everywhere you don't have to search and then change it yourself, right? You just have to make the edit inside the function definition and that will work. Next, function make code modular. So consider a big file having many lines of code. It becomes really simple to read and use the code if the code is divided into functions. So if your code is divided into function, it will become really simple to read. Next, we have functions provide abstraction. So for example, we can use library functions without worrying about their internal work, right? So what we can do, we can use library functions without worrying about their internal work. So function declaration. First we saw the function syntax, right? So syntax of the function, how you basically over here like give like make a function. Now we are going to look at your function declaration. So function declaration tells the compiler about the number of parameters the function takes, data types of parameters, and returns the type of function. Putting parameter names in the function declaration is optional in function declaration. So it's optional having parameters or not having parameters, that is completely optional. But it is necessary to put them in the definition, right? But it's necessary to put them inside the definition. So we are going to come to the definition. Right now we are on the declaration. So below are an example of function declaration. Parameters names are not there in the below declaration. Alright, so what we have int heading, right, and then void. So basically what we have, return type is integer, meaning that this function will return an integer, right? And then we have our function name heading, right? And parameters are none, right? So we are giving void, or we could have given nothing also, right? So this is considered as the header, right? And over here we don't have to give a semicolon, we have to give the curly brackets after this part, after giving the return type, after giving the function name, and after defining the parameters. We don't have to give any semicolon, we have to give the curly braces in which we have our statements, and then we are returning our integer, right? So this is the body where we have statements and our return statement, and this was the header where we had our return type, function name, and parameters. All right, so over here, here's an example. We have a max function that is returning an integer data type and is taking in two integers, right? So C++ program to show function that takes two integers as parameter and returns an integer. Next we have a function that takes an integer pointer and an integer variable as parameters and returns a pointer of type integer. So what we have a swap function, right, that will return a pointer with integer, a pointer, right, of type integer, right? And then it is taking it a pointer of type integer and a normal integer variable. Next what we have, a function that takes a char as parameter and returns a reference variable. So what we are doing, we are returning a pointer of type character, right? We are naming the function call, and what we are taking in, we are just taking a character value b. And finally we have a function that a fun function that is returning an integer data type and taking in a char an integer parameter. Alright, so there are two types of functions, library function and user defined function. So user defined functions are user or customer defined blocks of code specially customized to reduce the complexity of big programs, right? So these are basically the functions that you create, right, that you define, like this over here. These are all user defined as we are defining them. They are also commonly known as tailor-made functions. So you also call them tailor-made functions, which are built only to satisfy the condition in which the user is facing issues, meanwhile reducing the complexity of the whole program. And then we have library functions. So library functions are also called built-in functions. So these functions are a part of a compiler package that is already defined and consists of a special function with special and different meanings. So built-in function gives us an edge as we can directly use them without defining them, whereas in the user defined function you have to declare and define the function before using them. For example, square root function we have that we can use to take out the square root, right? And it's a built-in function or a library function, meaning it is already provided to us by the language and we don't have to create it ourselves. Then we have a setw function, we have a string cat function, and we have many thousands of built-in functions. So next we are on parameters passing to functions. So parameters passed two functions are called actual parameters. For example, in the program below, 5 and 10 are actual parameters. So what we are doing over here, we have gfg equals to 5, gfg2 is equals to 10, and we are passing the multiply function gfg and gfg2. So these are called actual parameters. The parameters received by the function are called formal parameters, right? So what we are doing, the when we are passing over here, these are called actual parameters. So gfg and gfg2 are called actual parameters, and over here when we are receiving them, int x and int y are formal parameters, right? So one more way, these are referred in normal language, these are referred to as parameters, and these are referred to as arguments. So actual parameters are mostly referred to as arguments, and formal parameters are mostly referred to as just parameters. So there are two most popular ways to pass parameters. One is passed by value and the other is passed by reference. So in pass by value, in this parameter passing method, values of actual parameters are copied to the function's formal parameters. So what is happening? The actual parameters values are copied in the to the function's formal parameters, and the two types of parameters are stored in different memory locations. So the variables like gfg and gfg2, the actual parameters memory location, so gfg and gfg2's memory location is different, and x and y's memory location will be different. So are stored in different memory locations. So any changes made inside the functions are not reflected in the actual parameter of the caller, right? So in passing by value, whenever you change your variable x or y inside this multiply function, it won't affect gfg and gfg2, right? So that is one advantage of passing by value, that it won't change your outside variables, right? And whatever changes made inside the function will remain inside the function and won't be highlighted outside the function. Next, we have pass by reference, that both actual and formal parameters refer to the same location. So whatever actual parameter you have like gfg and gfg2, and if we were passing by reference, then int x would have the same memory location as gfg, and int y would have the same memory location as gfg2. So any changes made inside the function, like to x or to y, are actually reflected in the actual parameters. So if you change the value of x, that will actually change the value of gfg, and if you change the value of y, that will actually change the value of gfg2, right? So in pass by value, the changes were not highlighted outside of the function, right? And in pass by reference, changes were highlighted outside the function. There's one function definition: pass by value is used where the value of x is not modified using the function fun, right? So over here, here's an example of pass by value, right? So we are creating a fun method that is basically returning nothing, right? So we are giving void, right? And it is taking in x, right? And it's setting just the value of x to 30, right? And when we are creating inside the main function x equals to 20, right, we are calling function and passing it x, right? So that was setting x to 30, but the changes won't be highlighted outside this function, right? So over here, the global x that was over here inside the main method, that won't be changed, and when we print the value of x, we will get 20. All right, now we are on functions using pointers. So as the class is about to end, we are going to continue in the next class, and let's just continue then. Thank you.
Okay, thank you.